Hi, Colin. This is Dave Moraine. I'm following up on your suggestion. This is sort of how I did it. So we have a polynomial, we substitute 5 in, and the synthetic substitution or synthetic division, the process is the same as if you were dividing the polynomial by x minus 5. See, we changed the sign to positive 5 as we are substituting in 5. So you put the coefficients on the top row. So we'll put in the 3, 4, and 0 for the constant term. And the algorithm is initialized by dropping down the leading coefficient. And then instead of the normal long division algorithm of divide and subtract, because the sign was changed, we're going to multiply and add. That's why this was developed as a shortcut to long division. It can be used for more complicated divisors, but that's not where we're going right now. So I told you we multiply. 5 times 3 is 15. Add. And we continue the process until we run out of coefficients, 95. So the 95 is the result of substituting 5 into the polynomial, or it is the remainder when the polynomial is divided by x minus 5. You'll notice that all of these numbers are multiples of 5. And these numbers, of course, are larger than 5, and the numbers on the top are our original polynomial. So I decided to try to reverse it, and I think there's more than one way to do this. Since we don't know the top row, we're going to start from here. So, knowing that this is 95, okay, the process ended here, so therefore I have to divide instead of multiply to reverse it. So 5 goes into 95 19 times. 19 times 5 is 95. That's what I meant by reversal. And in order to figure out the number above it, we subtract the opposite of add. Now, this has to be a multiple of 5 here. And if I use 5 or 10, then the number above it would be greater than 5, or 5 or more. And as we agreed, the coefficients have to be less than 5. So I'm going to use the largest multiple of 5, less than 19, which is 15. That makes this 4. Again, we're reversing the process, so we subtract. And this had to be 3, because 5 times 3 is going to give you the 15. 5, 3, 15. Since this is smaller than 5, we're going to stop the algorithm and reverse that initialization process, and then we read it off from right to left. So the 3 becomes 3x squared plus 4x, that's from here, plus 0. There were 3 terms, so the highest degree would be exponent 2. I should demonstrate this with other examples, but let me know if any of this makes sense. And I really appreciate your putting this problem up. The mathematics of magic, or the magic of mathematics, I love it. It would really turn kids on, and it got me excited. Thank you, Colin.